Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 169 derive the mass moments of inertia for the homogeneous thin rectangular plate of constant thickness T shown with respect to the x, y, and z axis. So although not labeled here, so the thickness here is denoted by T, and the mass of the rectangular plate is equal to density of the material times the volume, and the volume is the area of this rectangle, which is B times C times the thickness. So let's consider a differential element of area dA, and the distance of dA from the y-axis is z, and from the z-axis is y, as shown. So from the y-axis is z, and the distance of dA from the z-axis is y. The distance of dA from the axis perpendicular to the plane of the plate through the center of gravity G is r sub x, as shown. And Ix, the mass moment of inertia with respect to the x-axis, is equal to integral of Rx squared differential mass. From the figure, Rx squared is equal to y squared plus z squared. Supposedly z is negative, but since this is Rx squared, so negative z quantity square is still positive. So Ix is equal to integral of quantity y squared plus z squared times differential mass, which is equal to density, times differential area of the element times thickness, which is T. So this is the differential volume supposedly, and density times differential volume is differential mass. So putting density and T, the constants before the integral sign, so we have Ix equals density times T integral of quantity y squared plus z squared dA. If we expand integral of y squared dA, integral of y squared dA is Iz, and integral of z squared, distance of dA from the y-axis, is Iy, integral of z squared dA. So it is Ix equals rho times thickness Iz plus Iy of area. In short, Iz plus Iy of area is also the polar moment of inertia of area, which is with respect to the x-axis through the center of gravity, J of area, where Iz is equal to the moment of inertia of this rectangular area with respect to the centroid is C d cubed over 12. So Ix equals rho t times J of polar moment of inertia of the area with respect to the centroid. So it is equal to density times thickness times quantity C b cubed over 12 plus C cubed b over 12. This is Iy. So with respect to this axis, it is equal to C cubed b over 12. Then factoring out BC over 12, then we have Ix equals density times BCT over 12 times quantity B squared plus C squared. Since density times BCT is the area of the rectangular plate times thickness, which is the differential volume. So density times differential volume, this is the mass of the plate. So therefore, Ix is 1 over 12 mass times quantity B squared plus C squared. So that's it for this detailed derivation for the mass moment of inertia of this rectangular plate with respect to the x-axis with that orientation and dimensions. Now let's proceed to Iy. So Iy is equal to integral of z square, the constant distance is z square, times differential mass, and again differential mass is equal to rho dAt. So Iy is integral of z square rho dAt. Putting rho t before the integral sign, then we have rho times thickness integral of z square dA, and we interpret integral of z square dA as simply Iy. And Iy is equal to CQB over 12. So Iy is rho t times Iy of area. So it is equal to density times thickness times CQB over 12. Again, factoring out BC, combining with rho times t. So Iy equals density times VCT over 12 times C square. So we interpret this again as the mass. So Iy therefore is 112 mass C square. Then finally for Iz, we have with respect to the z-axis, it is equal to integral of y square times rho dAt. And putting rho times t before the integral sign, then we have integral of y square dA. We interpret again integral of y square dA, constant distance square dA of area as moment of inertia with respect to the z-axis, which is equal to cb cubed over 12. So Iz is rho t times Iz of area, and Iz of area is equal to cb cubed over 12. And we factor out Bc combined with rho and t. So density Bct over 12 times b square. So we interpret this again as the mass, therefore Iz is 112 mass b square. So that's it for this part, and I hope that you were able to follow the explanation, although I solved this in detail. For the next problem, we can proceed directly to this general expression, rho t times integral of or rho t times j of area, or density times thickness times moment of inertia of area. Level 170, derive the mass moments of inertia for the homogeneous rectangular prism shown of mass m with respect to the x, y, and z axis. So here's the given figure. Actually, we may use the results in level 169 to derive the mass moments of inertia with respect to the x, y, and z axis. Take note, observe that the x, y, and z axis are the centroidal axis, so it is passing through the center of gravity of this rectangular prism. So from the previous result, Ix is equal to rho times thickness times j of area, jg of area. So for the solution, let's have that strip. So we have y prime, z prime, and the distance between y and y prime axis, or z and z prime axis, is x as shown, and the thickness of this element, which is a slab, rectangular slab, is dx, also as shown. So from the preceding result, Ix is equal to rho times thickness, which is in this case thickness of this rectangular element dx, then times jg, the polar moment of inertia of area, gg prime of area. So gg prime is simply iz prime, iy prime plus iz prime through the centroidal axis, and this x-axis is perpendicular to the plane of that element. So where dx, because this is the only variable here, gg prime is constant, so integral of dx is x, limits from negative a over 2, because this is the centroid. So negative a over 2 to positive a over 2, and that would be equal to simply a. So rho times a, then gg prime is equal to iz prime plus iy prime, and iz prime is ab cube over 12, while iy prime is c cube b over 12. So factoring out bc, so it is ix equals rho abc over 12 quantity b squared plus c squared. Since density times abc, where abc is volume, is the mass of the rectangular prism, so therefore ix is 1/12 of m quantity b squared plus c squared. Likewise, for iy, it is equal to differential iy is equal to differential iy prime. So this is through the centroid of area or mass, differential mass, plus differential mass times distance between y prime and y axis quantity square by transfer formula or by parallel axis theorem. So differential iy is differential iy prime plus differential mass times distance between the axis y and y prime. So this is by transfer parallel axis theorem. And differential iy prime, which is this, is equal to, from the preceding result on rectangular plate, thin plate, it was density times thickness, the thickness is dx, times iy prime of area. While differential mass is simply BC, the area of the rectangle, times thickness dx, times density, or density times area of the rectangle times thickness dx. So differential iy is equal to rho times density times thickness dx. Then this is the differential mass, by the way. Density times area of rectangle, which is c times b or b times c, then times thickness dx. So differential iy is equal to rho times dx, thickness, rho density times thickness, iy prime of area, plus x squared times differential mass, density times bc dx. So in this part, the only variable here is dx, and integral of dx is from negative a to a over 2 is simply x, and up substituting the lower and upper limits, that's why this is just a. If we integrate that, then here we put rho bc before the integral sign, then integrate x squared dx. Limits of x would be from negative a over 2 to positive a over 2. So iy therefore is equal to density times a, then iy prime of area is simply equal to cb cube over 12, which is this. Iy prime of area is c cube b over 12. This is the y prime axis, so it is b c cube over 12 or c cube b over 12. Then plus rho bc, integral of x squared dx from negative a over 2 to positive a over 2. So iy is equal to rho abc, quantity rho abc over 12 quantity c squared, then plus rho bc x cube over 3 from negative a over 2 to a over 2. So take note that this is mass. Iy therefore is mass c squared over 12 plus rho bc over 3 quantity a cube over 4, because a over 2 cube is a cube over 8 minus quantity negative a over 2 cube, which is negative, so minus negative a cube over 8 So that would be a cube over 8 plus a cube over 8. That would be a cube over 4. So rearranging, Iy is mc square over 12 plus rho abc over 12 times a square. Then we note that rho abc is mass. So mass over 12 factor out. Then you'll have c square plus a square, or mass over 12 times a square plus c square. So let's write a square first. Therefore, Iy is equal to 1/12 of mass times quantity a square plus c square. Then, then for Iz, so differential Iz is differential Iz prime plus differential mass x square, because the distance between the z and the z prime axis is still x, and the thickness of the plate is still dx. So therefore, uh, differential Iz is equal to rho times thickness dx Iz prime of area plus x squared, then differential mass is rho bc dx, which is this. Integrating, and we note that the only variable for this first term here in the right side is dx. Integral of dx from negative a over 2 to a over 2 is simply x. Then a over 2 minus negative a over 2 is a, so we replace this by a. Iz prime of area with respect to this axis is cb cube over 12, which is this. So Iz equals rho a times cb cube over 12 plus rho bc integral of x squared dx, which is the same results there. So Iz equals rho abc times b squared over 12 plus rho bc times x cubed over 3 from negative a over 2 to positive a over 2. So Iz is equal to mb squared over 12 plus rho bc over 3 quantity a cubed over 4, just like before. So we then write it at m over 12 times a squared plus b squared, because rho abc, this is rho abc over 12 times a squared, and rho abc over 12 is mass over 12. Factor out mass over 12, then what is left here is a squared, then here it's b squared. So that is Iz, mass 1/12 of mass times quantity a squared plus b squared.